In this video, we're going to study how to calculate or how to evaluate vector line integrals. Now, these can be called line integrals, or alternatively, they can be called contour integrals. The correct spelling for contour is this one. So line integrals or contour integrals. So we are doing these in the context of vector calculus. There is a corresponding topic in the calculus of complex numbers. So there you also find yourself having to work with line or contour integrals. It is worth mentioning that the mechanics, whether it's in vector calculus or complex calculus, the mechanics of working out, or the techniques of working out line integrals is going to be identical, exactly the same. So if you're doing this, you haven't done a complex calculus, expect to meet it in complex calculus. If you have done complex calculus, then the techniques are identical. All right, so the main one of the main applications of the line integral in real calculus is to find work done. So in these examples, we're going to find the work done in moving an object along a given path, which we're going to call C, under the influence of a specified vector field or force field. We're going to look at these two force fields in our examples. So the plan for this video is to cover A and B. So in A and B, we're looking at working out the work done in moving an object from -2, -1 to 1, 5 along this the straight line joining the 2 points under the influence of the first vector field here. And then for B, we're going to do from -2, 4 to 1, -6 under the influence of G. All right, so let's get on with the first one then. So just to make a sketch of the situation, so we're going to be working out the work done in moving an object from -2, -1. So maybe somewhere there, -2, -1 to 1, 5, somewhere there, 1, 5. So this is going to be our contour, the straight line. So we are going, let's say, from A, or moving the object from A to B under the influence of this force field. So the formula for work done is so W for work done is the contour integral, or the line integral, of f dot dr along our curve C. So because dr is dxi plus dyj, then when you take the dot product of these two, then our work done is going to be 6x squared minus 2y dx plus 3x plus y dy. So this is the integral we want to evaluate. So the way we work out this integral is by finding out the formula for the contour C, and then using that formula to express this integral in terms of one variable or parameter, because as you can see now, it depends on both x and y. So we are going to make it a function of just one variable using the equation of our contour. In our case, our contour is a straight line. So the first thing we want to do is to find the gradient of the straight line by doing difference in y over difference in x. So it's going to give us 6 over 3. That means our gradient is 2. And so if we use the 1-point form of the equation of a straight line, this gives us the equation y is equal to 2x plus 3. So this is the equation that we can use to express this integral in terms of one variable. For our purposes, we are going to look to express everything in terms of x. So from here, dy is going to be 2 dx, which we can plug in there. And then everywhere we come across y, we can express it in terms of x using that formula there. So what's going to happen is then our first term, which is 6x squared minus 2y, is going to look as follows. So we're going to have 6x squared minus 2 into 2x plus 3, and then dx just remains like that. And then the second term is 3x plus y. So we're going to have 3x in the place of y. We're going to plug in 2x plus 3. And then dy, we've just worked it out here, is 2 dx. Then after that, what we need to do is to remove brackets and simplify. Oh, by the way, since now this is an integral of x only, then we can write the limits in terms of x as we go from the beginning of our contour to the end point. At the beginning, x is -2. At the end, x is 1. So that means instead of just writing c there, we can write this is going from -2 to 1. And so this is now just a regular definite integral. Okay, if we simplify the first set of brackets, we're going to have 6x squared minus 4x minus 6. From the second set of brackets, this is going to be 5 times 2, so that's going to be 10x, and then 3 times 2 is 6 dx. And so this is going to be simply 6x squared. The 6 minus 6 and plus 6 is going to cancel out here. 10x minus 4x is 6x. So we're going to have 6x squared plus 6x dx. This we can integrate, not a problem. It's going to be 2x cubed plus 3x squared. Then we plug in 1. When we plug in 1, it's just going to be the sum of the coefficients. It's going to be 5. Then when we plug in -2, this is going to be 16. This is going to be 12. And so this works out to 9. So the work done in moving an object from this point A to that point B there, under the influence of this vector field, is going to be equal to 9. All right, so at this point, what we are going to do is we are going to give you an opportunity to have a go at this example number B here. So what you can do is to pause the video, work through example number B. It's very similar in structure to what we did there. It's a straight line contour again. It's just a different straight line and a different force field. And then when you continue the video, then you can compare with our solution. Then in part 2, we'll go to do C and D. In part 3, we'll go and do E and F. Right, so for now, you have the opportunity to have a go at B. Okay, we are now going to scroll down to our solution for B. So by the way, if you have got any questions on the stuff we're doing here, on any of the steps we have done or ideas, concepts, feel free to post them in the comment section, and we hope these are helpful and useful for you. Please do not forget to, of course, press the subscribe button, like the video, and yeah, all right. So in part B, we've got the contour is a straight line from -2, 4 to 1 minus 6. So again, we need to find the equation of this straight line. The gradient is -3. Equation works out to -3x minus 3. And so, because we need to write this expression for the work done in terms of one variable, then we find that dy is -3 dx here. So this is going to be -3 dx. And then if we plug in y is -3x minus 3, wherever there is y, this is what we're going to find. Dy is, of course, -3 dx. Then if we remove brackets, first set of brackets works out to 2x minus 9x minus 9. Second set of brackets is going to be 5x plus 6x plus 6. We still have this one here, and then if we multiply through, this is going to be 11 times 3. It's going to be -33. There's going to be that. And then we combine these two. And now we can integrate. If we plug these, we find that the work done is -21. All right, so thank you for watching. In part 2, we are going to go on with the next two examples, which is C and D. And then in part 3, we're going to do E and F. In C and D, we have got a parabola in both cases. And in E, we've got an ellipse. In F, we have got a circle. Thank you for watching.